Uh, Hi folks, in a previous video we talked about how to identify if a problem is something that can be solved by using u-substitution or whether you should use integration by parts. So I had a list of 10 problems and kind of mentioned the techniques that you can use to figure out which is the right method to use. But here I'm going to go ahead and solve some of those problems, so because there were some people that were interested in knowing how they are done. So let's look at this. So this problem, is this going to be integration by parts or is it going to be a u substitution problem? So what I look for is if you have anything like a radical or an exponent, anything of that sort, and if you find a term, for example here 2x cubed plus 6, if you can take a derivative of that, and if that turns out to be the rest of the terms in the integrand, so then you have a u substitution candidate. So for example here we can take 2x cubed plus 6 as u. Why? So if you take the derivative of 2x cubed plus 6, so you have 2x cubed plus 6 dx. What do we get? So we get 6x square plus 0, because the derivative of 2x cubed is derivative of x cube is 3 times x square, and you multiply with 2 you get 6x square, and the next part is just a constant. If you take a derivative of a constant, all you get is a 0, so that's equal to 6x square. So you can see that this is just nothing but a multiple of x square, which is the other term here. So clearly it's a good candidate to try using u substitution to solve the problem. So let's go ahead and do that. So in this case, let me simplify this a little bit. So we get du dx of the term came out to 6x square. So which means you can write du as equal to 6x square dx, or if you take 6x square to the left hand side, we get du over 6x square is equal to dx. So now if I take my u and substitute, replace 2x cubed plus 6 and also replace dx with whatever we came up with, and let's see what we get with that. So this integral so basically becomes, this is equal to, so integral x square, integral of u dx, I'm replacing with whatever we have done so far, so that becomes 6x square. So this is equal to 1 over 6. Let's bring that out. So x square and x square get cancelled, so you get square root of u du. And notice that square root of u, you could always write it as u to the power of half. So if you take this as u to the power of half du, and this becomes a fairly straightforward formula for integration, you should know this by now. So this would become u to the power of half plus 1 divided by half plus 1, and that becomes this 1 over 6 u to the power of 3 over 2 times 2 over 3. You might want to note that half is nothing but 3 over 2, and since it is in the denominator, we flip it, we get 2 over 3. So the answer becomes, so this I can't see the cursor, so that's why I have to click this thing to figure out where the cursor is. So this is 1 over 6 times 2 over 3 times u to the power of 3 over 2. So that's same thing as 1 over 9 times u to the power of 3 over 2. But we are not done here. So if we still have to convert u, put it back in terms of x. So what did we have u as? So u is 2x cubed plus 6. This one is our u. So wait. So this becomes 1 over 9 times 2x cubed plus 6 to the power of 3 over 2. So that's our answer. I noticed I did write something slightly incorrectly. This should have been just without u. I should have just written d of 2x cubed plus 6 over dx and maybe mention that u is 2x cubed plus 6 here. So anyway, so that's the first problem.